Today, we are going to see about the corrosion of steel in concrete. This subject I have divided into three parts. First one, the various components that is being affected by the corrosion in various structures. And the second part is going to be the mechanisms and how the corrosion of steel is taking place in the concrete. Third one, how to prevent it, to overcome all those things. These are the three components. Now first let us see various structures, how it is being affected by the corrosion. First one, you see this sunshade. The sunshade is affected by it because of accumulation of dirt and other debris that is being loaded on. So at the sunshade, just blocked, and water is standing there. The water is percolated through the concrete. Corrosion took place in the steel. Corrosion of slab at the bottom, it is taking place because of the percolation of water from the roof, and bottom it is accumulated. The cover concrete is detached and it is fallen down. Next is, you see near the sunshade, the lintel concrete is being lintel is affected. The water got inside, corrosion is initiated, and around the steel bar, the corrosion is taken place. If 1 mm thickness will go into corrosion, it will produce 6.5 times the volume of 1 mm expansion. The rust product that is formed around the steel goes up to 6.5, and that induces stress called hoop stress. That when the hoop stress exceeding the tensile strength of the concrete or the plaster, then the concrete getting deteriorated. This cracking starts. So this is how it has come. The stress produced by the corrosion product is exceeding the tensile strength of the materials. That is why the concrete cracking taken place here. Third one is, you see the bottom of the slab is deteriorated and it is falling is taken place. The stirrups are exposed outside. The stirrups, and here the sunshade, and the other side the beam stirrups, everything is deteriorated because of the fume that has come from the industry. That is corrosive gases, which consist of chlorides, sulfur, carbon dioxide, sulfates, all these things that comes and attacks this. You see the vertical column, sunshade, and then there the beam, everything is exposed there. Beam is also getting deteriorated. This is a column. Spalling has taken place and rods are exposed. This is very dangerous condition. We need repair work or anything. That after examination of the steel rods, remaining steel rods, the thickness of the rod, diameter of the rod, how it is remaining, and other structural functions has to be analyzed, and then the remedial measure has to be taken. You see here also, there is a rainwater pipe. The rainwater pipe is connected to the rooftop, and there are debris that are accumulated over the roof, and there is no path for the water to go, and the standing water gets percolated inside, and because moisture is saturated in the corroded, expanded, and bottom it is all seen. See, bottom is exposed there. These are all piles driven in that is in seawater. This will go up to the bed, and even further also it may go. It has got a circular. It is a circular pile. Has got a circular metal sheet for each column to contain it, and the concrete is poured inside. So steel plates, the thick steel plate which forms the pile, getting deteriorated by the seawater. And here you can see this bacteria and other things are attached to the steel and is getting accumulated. You can see in the high tide and low tide. Here you can see high tide and low tide. In that you can see small attachments. These are all nothing but the bacteria that is going and getting attached with the steel plates, and then it consumes the organic matter in the seawater, and it excretes, and the excreta of these bacteria are highly low pH, and affects, and steel also getting deteriorated. One is the chloride attack. Second one is the bacterial microbial activities that also spoils the steel. And here also the coping. This is a pile, top piles, bottom is pile, top is the RCC coping slab, and that also exposed to chloride environment, and corrosion has taken place. Chloride is the main culprit for the corrosion. Near the corrosion is ravaging the columns. So many columns, column cover, everything is fallen down because within no time. The concrete cover is very small thickness, maybe 1 inch or 1.5 inches or 2 inches at the maximum, through which the chloride laden air getting into it. This is not a perfectly waterproof. So the chloride go into that, accumulate, and corrosion starts. That we will see in the second part. And you see here the column, it's also affected. It is taken in one industry. The column is getting corroded, and other places you can see the beam bottom. You can see they're running along the beam at the soffit of the beam. This is the column is exposing the reinforcements. And here it's inside the room. There it is a laboratory like that. Fumes comes and goes top, and spalling is taken place. See this spalling. This is a roof bottom. It is taken in some industry. Column and other things are got corroded. See here also the column is affected. Rods are exposed. Corrosion is such a serious matter. We should take very care steps we have to take to avoid this. See here how the structures are affected. So far, what we have seen is the various structural elements affected by chloride and bacteria and fumes, industrial fumes, and how the damages taken place, how rods are exposed, how the concrete is fallen down and exposing the rods. So these are the corrosion damages we have seen to. These are corrosion damages normally that is taking place. In marine area, it is very much affected. That is what we have learned so far in these slides.